Hey everybody, Miss Dietrich here. We're looking at question number 9, which is a little tricky, and really the strategy that I call think of a simpler problem should help us to know what we need to do with these two mixed numbers in the problem. The problem reads, Vera estimates that it will take her 16 and 2/3 hours to complete a project for her playwriting class. She spent 4 and 1/6 hours working on the project last weekend. What fraction of the time needed to complete the project did she work last weekend? So she starts the project, and then she spends all these hours, and then finally she finishes. Now, to use this strategy, think of a simpler problem. We're just going to round numbers to being compatible. So if we round this to 16 for compatibility purposes, and round this to 4 for compatibility purposes, and kind of map it out and look at what fraction this is, you can visually see that that's 1/4. So the question is, what would I have to do with these two numbers to get 1/4? Well, what we'd have to do with them is we'd have to divide them. We'd have to do 4 divided by 16. Or we could look at it this way, 4 divided by 16. And if we simplify that, aren't we going to get 1/4? And isn't 1/4 a fraction? Right? We want a fraction. Now, we're not going to be doing 4 divided by 16, but let's model what we are going to be doing after this. Instead of it being 4, because it's actually a little more than that, right? If we kind of model this at 4 and 1/6, it might be, maybe about like that amount. Instead of the total time that it takes, instead of it being 16, it's going to be a little more, like it might extend out here. So if we were to draw a blue line to represent the 16 and 2/3, it might be something like that, right? And we'd have to move the finish to being over here because the 16 would be about here. Now, again, if there were whole numbers, we'd be doing 4 divided by 16, but they're not. They're mixed numbers, but we're still going to divide the two values. Now, when we divide these two values, step 1, improper fraction equivalence. Something sixths divided by something thirds. To get the something, we multiply the denominator times the whole number, which would be 24, and add in the numerator, which makes that 25. All right, 3 times 16, a lot of folks don't have that committed to memory. If that's you, then you would have to do the side computation. We get the 18 here. 3 times 1 is 3, 1 more is 4, and then we have to add in the 2. So that makes that 50. Now with division, remember to come up with the quotient. We need to keep change flip. Multiplying by the reciprocal of the divisor is the same thing. So we're going to keep the 25 sixths, change this to multiply, and change this to its reciprocal, which is 3/50ths. To keep the numbers more user-friendly, we would want to take advantage of some cross-reducing opportunities. 25 is a factor of both of these. It'll go into that once. It'll go into that twice. 3 is a factor of both of these. It'll go into that once and that twice. Now we're ready to go across and get our answer. 1 times 1 is 1. 2 times 2 is 4. Now, just as it turns out, the exact answer happens to match our estimate of 1/4. Now, there is a workspace to fill in. See, it does say show your work. So I would recommend showing everything you see on the screen. You might have to pause it and play it back again. But this is your final answer. Now, part B says something about doing a check. Let's see if we can look at that. Explain how to check that the quotient you got in part A is correct. So for the check, recall that we said that if you take the quotient and multiply it by the divisor, you should get the dividend. So in other words, 1/4 times 16 and 2/3 should equal the dividend, which is 4 and 1/6. So you might want to go ahead and show the work for this to show that the two sides are equal to each other.